So this is a question from a year 12 paper, and basically we're going to be using some trigonometric concepts and some trigonometric identities um, along with algebraic techniques to simplify this trigonometric expression. Okay, so I'm just going to write it down again. We can go through this together. So we have to simplify sine x is equal to cos x minus sine x plus sine x is equal to cos x plus sine x. Okay, so to go through this one, what we're going to do is obviously first we're going to put everything into one denominator, right? So over here, what we're going to do is we're going to do sine x, and then we're going to do cos x plus sine x. Now I'm going to show you guys all the steps so you don't get confused. And then this is over cos x minus sine x. And then we're going to plus sine x. And now I'm going to do cos x minus, I'm going to times out by cos x minus sine x. Sorry, I forgot to add that in the denominator as well here. Cos x minus sine x and cos x plus sine x. Okay, and then over here we have, again, same thing, same denominator, that's the aim. Cos x minus sine x and cos x plus sine x. So obviously now that we have the same denominator, now we can add these fractions together. So what we'll do is we'll have sine x and then cos x plus sine x plus sine x cos x minus sine x. Okay, and then in the denominator, we have, our total big denominator now, cos x minus sine x times cos x plus sine x. Okay, so that's the first big step done. Now what we need to do is from this one fraction, now we need to do all our factorizing and simplifying and make this into a nice simple equation. So over here, what we're going to do is we have sine x common here. So if we factorize out sine x, then we have cos x plus sine x, and then plus cos x minus sine x, right? So what I'm going to do is I'm just going to do the numerator for now, just so I don't have to keep writing the denominators. I'm just going to complete this. So this is just the numerator, right? So I'll just write that down here. This is just the numerator, okay? And then we'll simplify the denominator and then we can put it together. The numerator is this. Now cos x plus cos x is equal to 2 cos x, and sine x and minus sine x cancels out. So this we're basically left with 2 cos x sine x. Okay, that's the numerator. And then the denominator is just, if we expand this, cos x times cos x is cos squared x. So this is just a difference of 2 squares. So this just becomes cos squared x minus sine squared x. Okay, now there's not much we can there's not much we can do to the numerator for now as such. 2 cos x sine x. There's not much, but what we can do is we can definitely have a look at this denominator, right? So in this denominator, cos squared x minus sine squared x, that is actually a trigonometric identity. So if I show you guys, if you guys have seen this identity, you may have not, but this is in year 12. It's a pretty common one. It should be on you guys' reference sheet, or depending on which exam you guys take. But if you guys remember this identity, it's cos A plus B is equal to cos A cos B minus sine A sine B. Now you may be thinking, okay, how does this relate to this expression that we have here? Now, if you look closely, imagine that both of these values are just x here, right? So if you have just cos x plus x, right, which is, by the way, just cos 2x. But just for illustrating purposes, if I just have cos x plus x, well, then that's equal to cos x minus sine x, right? And now cos x times cos x is equal to cos squared x, and then sine x times sine x is equal to sine squared x. And this is exactly the same thing that we have over here. Right, so I'll just highlight that as well to show the similarity. So basically, cos 2x is equal to cos squared x minus sine squared x. Okay, so instead of cos squared x minus sine squared x, what we can write here is, we'll go back to black. This is equal to 2 cos x sine x over, so 2 cos x sine x over cos 2x. Okay? Now, what's the next thing we can do? Now, this top part, we can also use a trigonometric identity to fix up that one. So in fact, that one, so similar to how there's a trigonometric identity for cos, there's a trigonometric identity for sine as well. So we're going to go through that one now. So let's go through that, and we'll do that above cos. I'll put that here. And basically, the sine identity says that sine A plus B is equal to sine A cos B plus cos A sine B. Right? Now again, if we look at what we have here, if we just do sine x plus x, that's equal to sine x cos x plus cos x sine x, which is again just equal to 2 cos x sine x. Okay, same thing as we have in the numerator. So again, we'll highlight both of those. There's 2 cos x sine x, and there's 2 cos x sine x. And this is equal to sine x plus x, which, as you know, is obviously just equal to sine 2x. So these are called the compound angle identities. Well, they should be on your reference sheets. But you would just have to check depending on which exam you guys take. But yeah, so now this is just equal to sine 2x over cos 2x. And we know that sine over cos is equal to tan. So that's just equal to tan 2x, which is your final answer.